Good afternoon. My name is Fabrice LUPO. I'm very pleased to present today at the Trade and Investment Convention through Eurosham in Trinidad and Tobago, a presentation about performance-based contracts for non-revenue water reduction and service improvement. This is about finding opportunities for transforming the industry and infrastructure through PBCs with the private sector. So briefly, before going through the presentation, who we are. So we are a concession and contracting company, a large company called Vinci. As you can see, basic information about the company and its world ranking. So the company is divided between concession, contracting, and construction. Our construction activity annual turnover is around 50 billion euro, and within the construction division we have major projects and also water and sanitation division called VCGP, Vinci Construction Ground Project, and this activity is doing around 1 billion euro turnover per year with 4,300 employees, and WMI is part of this division. So who is WMI? WMI Water Management International is a 100% subsidiary of Vinci Construction Ground Project, and we are in the market since 30 years with international experience in over 40 countries and about 100 employees. So our activity is about water and sanitation engineering from all sorts of studies, design and surveys for water utilities or water companies. We are also involved strongly into non-revenue water reduction as specialized contractor, along with all sorts of specialized services that we offer, like leak detection, pressure management, smart metering, etc. Finally, we are also involved in technical assistance or institutional strengthening, working as advisor for many utilities in the world to solve their water problems. So I am doing the presentation in the name of both WMI and Vinci today about PBCs. So my presentation is focused on the water industry. So to introduce performance-based contracts, I will first talk about a basic concept of water losses or non-revenue water. So what we see here is a typical IWA water balance where we can classify all the water that is used in a utility company or a system, what we call a system, from the production or the treated water put into supply up to the customers. So what is important to know about the water balance of any company is that it all starts with the system input volume. Generally, the bulk metering at the treatment plants or also at the boundaries sometimes with other utilities when water is sold or purchased to other utilities. So any utility needs to have a good understanding and good measurement of the system inputs, generally, as I said, through quality bulk metering. On the other side of the balance, we have the revenue water, which is basically the amount of water sold to the customers, whether it is through meters or unmeters connection. And the difference between the system inputs and the revenue water is basically what we are looking at, the non-revenue water. So the non-revenue water is made of three components: real losses, also called physical losses, apparent losses, also named commercial losses, and finally authorized and billed consumption. For instance, in some countries or in some cities, there is free water for gardening, for churches, or depending on the law. So this is generally not something we are very interested in reducing initially, unless it is done through an institutional process to change the laws and improve the way the water is delivered to his customers. But where we really need to look at is what we can recover from commercial losses, meaning water that is not billed to the customers although it is consumed. So we have of course all sorts of unauthorized consumption, illegal consumption, inactive customer with water, under accuracy of water meters, errors of all sorts in billing. And we also, of course, look at how to reduce leakage and any type of physical losses, meaning water that is not reaching the endpoint of the system. Water going through leaks on trunk main, distributions, lines, service connection, reservoirs, etc. So this is where we have the potential association between the public and the private sector to do performance contract to save this water and improve the revenue of the water company. So, performance-based contract, what is it and how do we define it? Performance-based contract, it is basically a contract between two parties, a client and a contractor, where the parties agree on some performance indicator or targets to be achieved over a period of time. So targets can be of all sorts of nature, like how to improve the service, from basic stuff like how to improve the number of hours in the day people get water, or improve the pressure when it's too low. We can also look at water quality improvements when customers are not satisfied with the quality of the water they get, and all sorts of other parameters that can be defined in the contract to measure the performance of the contractor. Now, if we look more specifically at non-revenue water, and what I said earlier, well, we have basically two components, no? The physical loss that we intend to reduce, and the commercial loss also that we wish to cut. So physical losses is basically pretty straightforward measurement of what do we achieve, in terms of reduction of the volume input, meaning the production, the water, the treated water that is produced and introduced into our system. So it can be measured at the production facilities, well, in terms of volume, cubic meter per day, gallons per month, liter per second, etc. is basically the same stuff, but different way of measuring it. Also, commercial loss now. How do we measure the improvement in terms of commercial loss reduction? So opposite to the physical loss, now we will look at how we increase water sales, meaning billed consumption, okay, or billable consumption. Can be also in cubic meter if it's the way customer are billed, or translated into money, percentage of increase, etc. Now there is a difference between physical loss and commercial loss is the revenue collection factor, because we can sometimes reduce non-revenue water, reduce commercial losses, increase billing, okay, people get higher bills, but if they don't pay, well, the revenue collection rate goes down and less money enters into the pocket of the water company. So we can also, in certain conditions, look at improving the revenue collection, okay, through the contract. Finally, an important thing to discuss about is how do we combine both physical and commercial loss reduction, because ultimately we want to reduce loss in a general way, and we want to make the client wants to be more profitable and the utility want to be more sustainable. So generally speaking, a proper performance-based contract to reduce non-revenue water, except in some specific situation, will generally look at reducing both physical and commercial losses. So we will combine indicators. So how do we define now the type of contract we want to do? Well, we have a pretty large range of contracts in the industry, from simple technical assistance, let's say, or program management contracts, to PPP. So I tried here to simplify a little bit the possibilities of contract, of PBC contract, and to see more or less which one is more efficient, which one is less efficient, and what kind of risk we are talking about. We can remember that when we talk about risk, we talk also about cost. So risky contract will obviously will tend to be more expensive at the end. So we need to keep that in mind. It's not always the best solution if we want to control the cost aspect of the project. So if we look, for instance, at program management with an incentive fee, meaning the contractor is defining what needs to be done, but is not actually doing it. So it may face issue with low efficiency in some cases. Well, if the client is also not efficient itself or not able to implement the action to reduce the losses. But of course, it's a lower it's a low risk contract in the sense where the contractor is not investing a lot of resources or material so on in the project, and it's probably going to be a low cost project. Now we can, if we progress through contract type, we will then have build contract or design and build contract with targets. Okay, that's why they are PBC. They are not only design and build contract, they are design and build contract plus objectives, contractual objective, targets to achieve. So now we come to more interesting project type, where we will have a better results generally, because the contractor is in charge of several aspects of the implementation, from designing the program and implementing it with specific resources. And also we will tend to increase in the scale of risk and cost. The ultimate step, let's say, before the PPP is the design, build, finance and operate contracts. So the operation, when we talk about PBC, is not necessarily the same as an operation or a concession contract in the water sector. We need to be careful with that, because we are not necessarily, the private sector is not necessarily operating all the system, of course, but only the non-revenue water reduction assets or the program. Okay, so it may have a different definition of operation. It can also be called a sustainability phase, not an operation phase, meaning when we have implemented certain action, we need to sustain them to maintain the non-revenue water level. For instance, if we have created a network partition, a network zoning, or DMA, what we call district meter areas, well, we will have to keep them operating through the sustainability phase and keep the losses low. Okay. These different options may or may not have financing included. Of course, it depends. The financing may be part of a different scheme. It is not an obligation, okay, because we are not in a PPP here scheme. But when we reach, of course, the PPP situation, now we do have to look at financing and include private financing and private equities. So, of course, the PPP, it will be the ultimate solution to implement the PBC, and will include all the range of possibility. So probably the last two options, design, build, operate, PPP, will probably be the more efficient on the long term, because there is a full control of the capabilities of through the private sector to design, to implement, to put the resources to finance the job and operate it. But it will also incur higher cost. Okay, so we need to keep that in mind when we define a PBC contract for water loss reduction. Now we look at duration of contract. So this is a very interesting part. We have seen all sorts of contract duration over the years. Some very short, some very long, and it's not easy actually to define the duration of non-revenue water reduction contracts. But I try here to do a simple matrix of analysis, and what we can see here is that basically what will increase the duration of the contract is the capex requirements and the initial situation. Okay, when we have a poorly managed utility with low capability, okay, well, we generally also have poor data, initial data, to understand what's going on in the network and in the system. And when this is combined with high capex requirement, when what we call capex is really assets that need to be implemented at the beginning of the NRW contract to better operate the system. Well, without entering into much detail, it is mainly the network zoning, okay? How we will do the zoning, the pressure zones, the DMZ, the DMA, or whatever we call it, and what other type of asset we need to control the system, such as SCADA, a reservoir overflow prevention system, meters, service connections, etc., etc. Okay, so when we look at contract with high capex requirement, we'll probably go to a longer term contract. Okay, 7 years, 8 years. We will come closer to management's contract in the water sector. Okay, it's not necessarily as high, of course, as long as concession contract for large infrastructure, but it still needs to be longer project to be financially viable. Okay, on the opposite, well, if we have a very efficient utility, excellent information, pretty much nothing to do in terms of capex, so everything is the network's zoning is there, is working, there is a SCADA, all the customers have meters, etc. Well, we can almost start working immediately, having good information and reduce losses. So it can be short contract, even 1 year, maybe 1.5 years, can be profitable in some cases if we are doing some specific action. Okay, so this is what the environment we work with in terms of contract duration. So to be a bit more specific, I will show here a simplified, and I will even say very simplified business model of utility where we want to implement a performance-based contract. So this utility here is, I call it virtual utility, is a company with 100,000 customers. So it's probably 400,000 to 500,000 inhabitants city with consumption of 200 liter per person per day. So this utility has an initial water losses problem. Okay, they are losing approximately 100,000 cubic meter per day. Okay, so that's, if you are more familiar with gallon, it's probably 20 to 22 million gallons per day of losses. And it is well represented also by a 67% non-revenue water ratio. So this contract here is designed as a 4 + 3 years contract. So we talk about the utility with quite some problem of management. Okay, so a long-term contract and somehow average capex investment. So the company may not be that poor in terms of resources, but still needs to do some investments, initial investment like zoning or metering. So in this example, well, the contract is set at a starting point of 77% NRW, or let's talk more in volume, with more appropriate 100,000 cubic meter. So we want to reduce the loss basically at half. Okay, so first thing we see is that if we want to reach 55,000 cubic meter per day of losses, so cutting by almost 50%, 45%, it's not going to be mathematically dividing by 2 the percentage of non-revenue water. Okay, so the non-revenue water in terms of percentage going from 67 to 48 is actually a huge reduction, okay? And it's more appropriate, and this is what is done now in the industry, not to use indicators in percentage which are influenced by the consumption, but use NRW figures in volume, okay? So this contract is basically intended to reduce from 400,000 to 55,000 cubic meters per day the losses. So the earnings of this contract, well, in this very, as I say, simplify example, because there are thousands of parameters that we normally took into account, but I try to make it simple and friendly to understand. We basically reduce the losses over 4 years. So we do the works mainly during the first 4 years, and then we sustain it for 3 years, okay, at a lower cost, okay. So initially we will invest 5 to 10 million US a year, and slowly reducing to a maintenance period of 2.5, okay. So the costs basically of the project over 7 years, as I say, it's a simplified model. There is no financing cost, there is no price escalation, etc., no inflation. But in this simplified model, the cost of the project is 32.5 million US, okay? And the savings are, in this particular case, 55 million US, okay? How do we calculate the savings? Well, is the amount of additional water sold in this simplified model at a price of $2 per cubic meter. Okay, I'm not taking into account any complex tariff structure. It's the basic model. And also the production of water. I am taking an example of 0.3 US, meaning 30 cents per cubic meter, okay? So I'm going to earn at the end 55 million US over the period, if everything goes well. So the model say, okay, it seems that it's a good contract. The client, the utility, is going to make 22 million US at the end of profit, let's say. And I also know that I have a max cash flow needs around the year 2 and year 3 of 10 to 11 million US when we do the biggest part of the works, and then it will slowly reduce, okay? The cash flow will become positive. So in this example, how do I set the targets of my PBC, okay? What do I ask my contractor to achieve, and how do I pay my contractor? Well, as I said, the contract cost in this example was 32.5 million US. But of course, in this cost, you have basically, if you look in detail at this cost, you will have 3 components, okay? First, you have assets, okay? The contractor will build chambers, will install a SCADA, will change meters, will change pipes. So these assets become property of the utility, and we have a lifespan sometimes much longer than the contract. So it's important to know first how much of the cost is actually assets, okay, earnings for the utility. Second, you have really the service, the works, the know-how to reduce NRW, the people in the ground, the software, etc., that will have another value. And of course, in this cost, there is, after including administration cost, tax, whatever, you will certainly have profits, which I took 5% as a standard profit in the industry after tax or after all other overheads. So if I look at the price this way, well, I am saying, okay, if my contractor comes and do all this work, well, he will intend to make 5% profit, okay? So the way I will set then the performance, okay, level from 0 to 100% will actually impact on the expecting savings or earnings for the utility, okay, and also the profit for the contractor, okay. So this is where we can define all sorts of rules, okay, with different steps. But I took a simple example here where I'm saying that, well, I'm going to give to my contractors a percentage of my earnings, okay, but I'm going to do it gradually, okay, reasonably. And if, or in this particular case, my contractor is really not efficient, okay, below 20% of efficiency, I will be very bad, and I will giving a very strong negative, in this case, incentive, so a penalty. So basically, I am intending to maximize the profit also of the water company, okay. If I am doing very, very good profits, okay, sorry, in this case, before incentive 42 million, well, it's not unreasonable because the profit is due to the excellent performance of my contractor. So to give him a share. But in this theoretical example, well, the utility is making 42 million profit at the end of the project, so he is giving back 6 million to the contractor, okay, still positive 35, and so on, okay. If the contractor is not performing good, as you can see, we come to a very low efficiency level, and it's becoming much less interesting. So once again, so summary of how we could imagine this contract. Well, I have my level of performance. So here I'm not explaining into detail, okay, what is into this performance, okay. This can be a blended of indicators, and well, we don't really have time to go into detail, but it has a simplified performance achievement, okay. I'm just saying if I am reaching all my objective, I will get 100% and non 0%, and then it's gradual, okay. So I have my contract cost, okay, what we still the same. Then I have my contractor cost plus my performance fee, okay. So what the bonus I give him. So in this particular example, in the last situation, the contractor's cost ends up less than the contract cost plus performance fee is less than the contract cost if my contractor is basically not performing. I don't want to basically make him make money other than recovering some of its cost, okay, and asset investment, okay. But that's a critical situation. So if I am, let's say, in a 75%, which is a quite good performance, well, in this example, well, I will have saved 66,000 cubic meters per day, reaching 53% NRW at the end, okay. So if I am at 66,000 cubic meters per day of losses, starting 100,000, I have saved 33,000, okay, cubic meter per day, probably 8 million gallon, if we're talking gallon for this contract. So my contract cost is in the range of 100,000 US per cubic meter per day saves. I am mentioning this figure because it is commonly a figure that a contractor will work around, or project will cost around that, sometime a bit more, sometime a bit less, but for this type of contract, okay. So in this example, well, we end up with a contractor making 4 million profits, okay, in fixed and variable, okay. His fixed profit is there, his variable is there, okay, according to the formula, and the utility making 25 So it's a good contract. And in this example, I will say up to 50% achievement is kind of an acceptable or good contract for everybody. Okay, contractors still make reasonable, not huge, but reasonable profit, and the utility too. Now, if we are below this breaking point, it's become to be a bad contract for the utility. Okay, even if penalties come into the game. So probably, if we see that the project after 2 or 3 years tends to not achieving more than 25% of his KPI, is better probably to stop it or find a way to restructure it because something is not going on well. Okay, so this is what I wanted to say about the breaking point here. So to conclude my presentation, I wanted to show one example of a contract that we have done in Jamaica more than 10 years ago. So it's the Northwestern Parishes project, NWPP. So this is a typical performance-based contract and design and build with a performance target. Okay. And this project was done in the region, the northwestern region of Jamaica. The main city is the tourist city of Montego Bay and the surrounding parishes. So it's a quite big area, but not that densely inhabited in terms of customers. So we have 45,000 customers in the area. So long length of pipe and NRW issues. Okay, so this area was in a difficult situation initially because we had a starting point with 72% of loss. And but at that time we defined a contract for with the client, National Water Commission of Jamaica, over 2 plus 3 year period. Okay, 2 years implementation, 3 years sustainability. So basically, it will come, if we go back to my table, to a medium capex requirement in a poor data, low capability situation, 3 plus 2. So we probably made a small mistake in this contract without doing 3 years plus 2. To be honest with you, we would have needed certainly 3 years of implementation, so of stronger works, and 2 to 3 years of sustainability. So it was not a perfect contract in terms of duration, but it was still good and enough to achieve some interesting results. So the project at that time, project cost was 15.5 million US, which will roughly be 20 million US today at today's rate, and it has 20% incentive. So the particularity of this contract is just that it was not 20% bonus, but 20% penalties, okay, equity penalties, in case we did not reach the target. Okay, so basically the same principle, but done the opposite way. So we had to, as a contractor, to secure 20% equity in an escrow account, and from this account, what at the end of the contract, the engineer of the contract and the client and ourselves, in a tripartite agreement, we had to agree on the KPI and the target achievement and define, well, how much money go back to us and how much money go back to the utility. Okay, so this contract, without going into detail, we don't have time, actually was interesting because we were able to reduce the loss to 58%. So the target was 53. Okay, so if we look a bit more at detail, what the contract actually did well was achieving the consumption increase. Well, we did a lot of metering, detection of illegal connection, regularization of unmetered account, and so on and so forth. It was strongly orientated toward commercial works, so we did pretty well in this aspect. Was a bit more difficult, as you can see, in terms of commercial loss, physical loss, sorry, leakage and so on, reduction. We had to face a difficult situation, as I say, very extended network, old pipes, hundreds of reservoirs. I'm not talking of tens, but hundreds of water storage area in the hills around Montego Bay regions. So with overflows problem, high pressure problem. So it was not that easy, okay? We were a bit too ambitious, but we still had some good impact on controlling the production, reducing the production, but not enough to make all the target. But still, the project overall achieved 55% of its target, okay? So despite some difficulties at the end also in terms of budget to sustain and transfer the knowledge and the technology to the NWC, who was restructuring at the time. So despite probably some difficulty at the end, the contract itself during its duration was a good contract, okay? We can say it was a good PBC, pretty straightforward contract, good calculation method. The data were all reviewed by an engineer, external engineer. So I think everybody was happy with the job. So the contract costs around 600 US per cubic meter save, okay? It will probably be 700 US today, so it was, I would say, good value for money, probably a bit lower than the average in the region, and profit also was good for the NWC, 8 million US, okay, 10 million US at today's cost, and so return on investment around 40% to 30%, let's say, if we include all the financing aspect of it, because this contract was also financed externally, so there was some financing cost. So it's a typical example of what can be done, you see, in a small, in this case, in a small to average size city, okay, and it can be reproduced elsewhere at different scale and adjusted to the situation, okay. So this is where I'm concluding my my presentation. I hope it was interesting, and I will be pending for any question you may have. Thank you very much, and have a good day.